Now today we are starting with the one new question that was on symmetric and skew symmetric matrix. If this is one matrix given having element 5, 2, x, y, z minus 3, 4, t and minus 7, then question is this matrix is symmetric, then find out what is x, y, z and t. Now, one thing is clear, whenever there is a symmetric matrix, I told you Aij will be Aji. We have already done this. Aij will be Aji. That means this element is what? A12 should be equal to A21. So that means this 2 should be equal to y. So first condition we got y is equal to 2. Then this element is A13 should be equal to A31. So x should be equal to 4. And then this element z, can you calculate? Z is any real number because z is a diagonal element. It is not going to change its position. So z can be anything possible in this case. It will remain symmetric. What about t? Then this element will be A23 should be equal to A32. That means T will be equal to minus 3. So A12 is y is 2, then x is 4, T is minus 3 and Z as it is a diagonal element, it is not going to be compared with any of the element. We will say it will remain any real number or any imaginary number, any number it can be possible. So we should have, this is the example we have in which the matrix is given symmetric and we have calculated unknown values. Now we are coming on the second part. One more question please. That question says one square matrix A that is symmetric as well as skew symmetric. One matrix A given as Aij, it is a symmetric matrix. Symmetric matrix means it will be first or square matrix and it is given that A is equal to A transpose and the second condition which is given as A is equal to minus of A transpose. Symmetric as well as skew symmetric. My question is prove that this matrix will be a null matrix. This is only possible when a matrix is a null matrix, then symmetric and skew symmetric will be equal. Whenever you have symmetric condition, we have done Aij will be Aji for all I and j. Second condition, when it is a skew symmetric, Aij will be minus Aji for all I and j. Right or no? This is condition for symmetric. This is for skew symmetric. As these are symmetric and skew symmetric conditions, that means we will say both are going to hold. That means this equation and the equation both are going to hold. That means if I add these two, this is equation 1 and this is equation 2. When you add it, it will come to Aij will be equal to Aji minus Aji. So this is coming out to be 0. So that indicate Aij twice is coming 0 or I should Aij is coming 0. Aij is coming 0 for all I and j. That means what you should say, this will be a matrix which will have each and every element 0. That means it will be called as a null matrix. So these type of questions possible in symmetric and skew symmetric questions. This chapter we have done few questions. One, I told you any matrix can be expressed as symmetric and skew symmetric. Then second question I have done, if it is a symmetric, what should be the values? And third one theorem we have done. In that I told that if a matrix is symmetric as well as skew symmetric, there should be a null matrix. Now coming on next topic, determinant of a matrix. Very important result, very important topic we have. Determinant, always we have 4-mark question, but first we are only going to know about the determinant. Again I'll go on matrix. First I'll introduce determinant chapter now, but we will complete determinant after completing matrix. So because we need in matrix some part of determinant, so I'm just introducing that and then we'll come back on the matrix. So here first, what is determinant of matrix? First thing we should keep in mind, determinant of matrix only going to calculate when it is a square matrix. So any matrix A which is a square matrix Aij, order n into n, every square matrix is associated with a number. This matrix is associated with a number that can be a real number, can be imaginary number, can be some expression. So any matrix which you are taking a square matrix has association with a real number or an imaginary number or an expression. Whatever this real number, imaginary number or the expression we are going to get for this matrix is called determinant of A, denoted by determinant A, or it is calculated by, or this is the symbol we have for determinant A. Either you write this determinant A or this is the determinant A. But how we calculate that number by which this square matrix is associated, we should know that. So how we calculate, just check. If we have a matrix A with order 1 by 1, that means it has only one element, then this matrix A will be having determinant value which is denoted by determinant A. This is nothing but this symbol is also going to change. It will come A1 1 and this determinant value is simply 1 1. So if it is 1 by 1 matrix, it will associate with the same number which is there inside. If we have 2 by 2 matrix, for example, if I have a matrix this A11, A12, A21, A22, and if I say you find out determinant of A here, then what I'm going to do, A11 we will multiply with A22. That means this element, first element multiply with this. So that is A11 into A22 minus second element will be this into this. That is A12 into A21. The difference of these two elements will be giving a number by which this matrix is associated and it is called as a determinant of A. Simple example, determinant A if you want of this number, or first I'll take matrix A. Let the matrix be 2, 3, 4, 5 and I want the determinant of it. So I'll write this in form 2, 3, 4 and 5. Then first these two will multiply, that will come 10. Minus will be there, I'll go by the reverse way, 4 3s are 12. So determinant value is coming minus 2. So matrix A has determinant value minus 2. By the way, if we have one more example, A is given as 2, 5, 7, 9. And if I say, or you take minus 5 here, then you take determinant A. This will be first 2 into 9, it's 18, minus 5 into 7. This minus will remain, minus 5 into 7. So 18 plus 5, 7, 35. 7, 5, 35 plus will be there, so it is 35. 5, 8, 13, 8 and 5, 13, 3 and 1, 4, and this is 5. 30, 40, 53 is the value of determinant we have. So this is 2 by 2 matrix. If you have, you know how to calculate determinant A. If it is a single element matrix, then the determinant value is simply the number. So that you should keep in mind. In next video, I'll tell you how we calculate the determinant of 3 by 3 matrix.